This is GM Word of the Week, and I'm Fiddleback. Moraine. It's important to note that we here at the Word of the Week are not the best planners in the world. Well, some of us are. But those of us who research and write the scripts and pass them along for fact-checking, editing, and recording, that person is not great at thinking ahead. Oh sure, sometimes it seems like we are. As, for example, when we put together a grand 3-part epic about the history of human exploration. But most of the time, we're just barely ahead of the curve. And that's why it's so invaluable when a random friend drops a couple of random words in conversation at about the same moment when the deadline for the week's script is just starting to loom a bit too large. That's why we're talking about moraines. Because the deadline was coming, and someone said something about them in earshot. Now, you may never have heard of moraines or tarns before, and certainly you may never have heard of them in a gaming context. But that's because they are the sorts of natural geological features that you don't realize are anything special. If you've ever created your own gaming world, you've probably sprinkled a few tarns around the world without even realizing it. Let me give you a more concrete example. While wandering around the lush mountain valleys in the southeastern corner of the province of Skyrim, in the 5th epic RPG in the Elder Scrolls series of the same name, you might have come across a small mountain pond called the Clear Spring Tarn. You might encounter some hunters. You might find MacGuffins to solve one of the quests you're on. You might find an enchanted bow and a book about the demon Veronicus and the heroic archer Borler, which gives you a healthy boost to your archery skill if you read it. And that sort of stuff is par for the course in Skyrim. Skyrim boasts a massive world filled with hundreds of points of interest littered with trinkets. But then that's pretty much been the defining trait of the entire series. Except it very nearly wasn't. The Elder Scrolls series exemplifies massive open-world exploration. It boasts 5 games in the main series, and a small collection of spin-offs and add-ons. And each one of the games has offered the players the chance to explore a different corner of the fantasy world of Tamriel. While each game features a main quest line that the player can follow, the game is pretty passive about it. Sure, Alduin, the World Eater, might be trying to usher in a scaly, fire-breathing apocalypse by resurrecting the world's dragons. But that's no reason to rush. Take your time. Take in the sights. Do a few hundred side quests. Join a guild. Pick wildflowers and craft potions. Get involved in the local politics. Buy a house. Get married. Adopt a child. It's not the end of the world. Amusingly, it isn't just the players of the Elder Scrolls game who get distracted from the main focus of the game with all of the side quests and side stories. The entire series owes its existence to random whims and distractions. The story starts with a man named Christopher Weaver. Weaver was a software developer and technology entrepreneur, and his area of interest was interactive technology. His first success was in developing training simulators for pilots. He then moved into broadcasting, where he became renowned for having his finger on the pulse of emerging technologies. While he started as the news director at NBC, he quickly became involved in their technology R&D department. Eventually, he became a congressional advisor on issues of communications and interactive technologies. And then, in the early 1980s, he discovered video games. The story goes that an engineer friend of his was working on a football-based video game, and he asked Weaver to take a look at the game. Weaver found it dull. It didn't behave like real football. It was just a series of statistics-based calculations. Weaver decided to teach the game physics. Basically, the idea was instead of asking the game to determine the outcome of a game based on statistics, he'd instead program the game to calculate things like where the ball would go if it was thrown with a certain amount of force at a certain angle. Thus, Weaver is credited as developing one of the first physics engines for a video game. A physics engine is just a computer program that knows the rules of physics and can apply them to the objects in a game world. And today, they're fairly ubiquitous. If you drop an item in a game and it goes tumbling and rolling down a hill, that's a physics engine at work. Weaver started a new company to produce the football game. He wanted to name the company Softworks, a portmanteau of software and workshop. But in his hometown of Bethesda, Maryland, that name was already taken by another company. On a whim, he attached the name of the town to his chosen name, and Bethesda Softworks was born. And in 1986, they published their football game, Gridiron, for the Atari ST game console and the Commodore 64 and Commodore 128 personal computers. Soon thereafter, Bethesda entered into a partnership with Electronic Arts to develop new iterations of the Gridiron football game. But EA quickly became uninterested in the project and canceled further development of the franchise. Then, very suddenly, EA released their own football game, which incorporated the statistics and names of actual football players, an endorsement in partnership with football legend turned sports announcer John Madden, and a complex physics engine that looked very suspiciously similar to the one that was being developed for the new iterations of the Gridiron series. Bethesda sued Electronic Arts for $7.3 million. The outcome of the lawsuit remains undisclosed to this day, but for comparison, to date, the Madden NFL franchise has earned EA upwards of $4 billion and has sold over 100 million copies. Things went quiet for Bethesda for a while after that. They were mainly known for developing licensed video games based on franchises like the Terminator, Home Alone, and the Where's Waldo book series. We kid you not. And then, in 1994, they decided to try their hands at a different sort of sports management game. They envisioned a fantasy game in which the player would manage a team of gladiators. The gladiators would travel from city to city, competing against other teams in various arenas. And they were even going to call the game Arena. But during development, the designers started to add little side quests and odd jobs your characters could perform between tournaments to build up their statistics and equipment. They added more cities with more side quests. The side quests got bigger, dungeons were added, and soon they had developed the first massive open-world computer RPG. By accident. But they had a problem. They had already been talking up their arena game, Arena, in interviews and promotional materials. But they'd accidentally gotten distracted from their main quest and built an open-world RPG instead. They couldn't completely change the name. Heck, a lot of promotional art had already been completed. So had the box art, which depicted a team of fantasy gladiators and nothing else. The only thing they could do was add a banner above the title. And so Arena became the Elder Scrolls Arena, because that had a nice fantasy sound to it. The actual artifacts known as Elder Scrolls didn't even make an appearance until the fourth game in the series. But enough getting distracted with side quests. Back to the Clear Spring Tarn and tarns in general, and moraines as well. Now, a tarn is just a small pond or lake, but it's a special kind of pond, because it's actually a scar in the world left by an ancient glacier, and a moraine is another sort of glacial scar. But to understand a moraine, we have to talk about glaciers and ice ages. While we tend to think of glaciers as massive solid hunks of ice, some the size of continents, they're actually more like rivers of ice. Very, very slow moving rivers. In fact, glaciers have the distinction of being the biggest moving bodies on Earth. How big? Well, the glaciers covering Greenland are nearly 2 miles thick at some spots. It's hard to picture a continent-sized mass of ice 2 miles thick moving, but that's exactly what they do. And to understand how they move, you have to understand how they form. Glaciers actually start their lives as nothing more than a pile of snow. When snow falls and partially melts, but then refreezes before it can melt away completely, it forms a mass of compacted granular ice particles called a neve. Now, normally, snow and ice fall in the winter and then melt away in the summer. But if the summer is too short or too cool and the snow and ice are thick enough, they don't melt away completely. A neve that survives the summer and lasts until the next winter is called a firn. And when winter comes again, new snow and ice fall on top of the firn, causing it to compact further. Repeat this process for dozens, hundreds, or thousands of years, and you get a mass of compacted snow and ice. And eventually, the weight of the new snow and ice is too much. And that's when two things begin to happen. First, the glacier starts to spread out. It's sort of like when you're making a pancake. As you pour more batter on top, the pancake spreads. Second, the pressure from the mass snow and ice can actually cause the bottommost layers of the glacier to partially melt. Thus, the bottom of the glacier can slide over the ground on a water slick. This is called basal slip. These combined forces, spreading and basal slip, allow a glacier to grind slowly across the landscape. Typically, glaciers move just a few feet a year, but some glaciers have been observed moving as much as 100 feet a day. Further, glaciers can experience sudden spurts of fast movement. These glacial quakes can be measured just like earthquakes, and generally occur when a stalled glacier suddenly breaks free of some obstruction. Today, if you want to find glaciers, you have to travel to a place like Greenland or Antarctica or go above the Arctic Circle. But not too long ago, in geological time anyway, not too long ago, glaciers were everywhere. Well, not everywhere, but they did cover all of Canada, much of the northern United States as far south as Indiana, Scandinavia, Germany, and parts of France and northern Asia. You've probably heard this one though, right? The Ice Age? That was a thing. Well, here's a bit of a surprise for you. The Ice Age wasn't a thing. It is a thing. A series of things. Present tense. Because we are still in the Ice Ages today. For at least the last 600 million years, the Earth has experienced sudden intervals of colder climatic conditions. During these conditions, the summers in the northern polar regions are short and cool and do not allow the snow and ice to melt. Thus, massive glaciers form and spread south, covering a portion of the northern hemisphere like icing on a cake. As the ice spreads, its shiny surface reflects sunlight, so the ground doesn't absorb any heat. See, most of the Earth's warming comes from the ground absorbing sunlight, heating up, and re-radiating that heat into the air to warm the atmosphere. If the light isn't absorbed by the ground, it isn't converted into heat. Instead, it just escapes into space. So as the glaciers spread, the world continues to cool. And that's what we call an ice age. Ice ages have occurred at widely spaced intervals throughout the recent history of the Earth. Starting about 600 million years ago, ice ages would occur fairly regularly every 200 million years or so. Each lasts for a few million years. Glaciers form, spread, the Earth cools, and then the Earth warms again, and the glaciers retreat. But the ice ages are not actually just a continuous freezing over. Rather, they tend to wax and wane. And that brings us around to why we say that we must refer to the ice age in the present tense, because we are, right now, in an ice age. About 50 million years ago, the Earth was much warmer overall than it is today. Spain, Europe, and most of the central United States actually experienced conditions we'd associate with the tropics. But things started to cool rapidly. 36 million years ago, the Earth experienced the first of 3 major cold snaps. The average temperature dropped by almost 15 degrees. The second cold snap started 7 million years ago, and the third started around 2.5 million years ago. And we're still in the middle of it today. We're in an ice age. So where are all the glaciers? Well, that's the thing about ice ages. Within an ice age, there are smaller cycles. Over the past 3 million years, glaciers have formed and spread across the northern hemisphere no less than 20 times and then retreated. The last major retreat was about 15,000 years ago, right around the time humans were just starting to become a thing. And that's generally what people think of when they talk about the Ice Age. That's when the mammoths and saber-toothed tigers and dire wolves and megatherium were all running around. But we're not actually out of the Ice Age. We're experiencing what's called an interglacial period, a period between the glaciers. And make no mistake, they will come back. In fact, the Ice Age has come back, a little bit. In 1939, geologist Francois-Emile Matthes first used the term Little Ice Age to describe a pattern noticed in records between 1300 CE and 1850 CE. It had been noticed that during those periods the weather had been particularly harsh. Many places on Earth experienced many hard winters and poor crop yields, especially in the mid-1300s. Records also indicated glacial expansion starting in the mid-1500s. More famines struck Europe in the 1600s, crops were destroyed, and flooding due to tremendous storms permanently changed the shapes of the Danish, German, and Dutch coasts. Now, it has been theorized by some scholars that the Little Ice Age, especially at its peak in the mid-1600s, has had a drastic impact on human history. See, it is widely known that fluctuations in the availability and price of food correlates directly with periods of social and political turmoil. And the 1600s were particularly turmoil-full. Heck, we've talked about some of these turmoils, such as the English Civil Wars and the 30 Years' War. But there were many, many other revolts, revolutions, and outright wars, such as the brutal Great Turkish War and the Wars of Spanish Succession. But beyond Europe and Eurasia, things weren't much better. In China, civil unrest was spreading across the empire of the Great Ming, the Ming Dynasty. Famine and disease were becoming widespread, and hungry peasants revolted against the high taxes and the pillaging of their crops by hungry soldiers. Citing their own grievances with the emperor and eager to take advantage of the situation, the Manchu family of the Qing Dynasty set about conquering all of China and overthrowing the Ming in a series of bloody conflicts that would engulf China for 70 years. But we digress. At this point, you might find yourself asking what causes these ice ages with such regularity, and what causes the regular glacial and interglacial periods within each ice age. And the answer is that we're not entirely sure. But we do have theories, and one of the most prominent was proposed by Serbian astronomer Milutin Milankovic. In the 1920s, he described what had become known as Makarenko Cycles. You know from our previous episodes that the Earth's climate and its seasons are caused by peculiarities in the relative motions of the Earth and the Sun. The fact that the Earth's vertical axis is tilted so that the North Pole points towards the Sun for part of the year and away from the Sun for part of the year gives rise to the seasons. And those seasons are further affected by the fact the Earth doesn't trace a perfect circular path around the Sun. Rather, it traces an elliptical orbit, meaning that the distance between the Sun and the Earth varies. Milankovic observed that these peculiarities weren't actually constant. For example, the elliptical orbit of the Earth stretches out sometimes. And that's due to the gravitational pull of the planets Jupiter and Saturn. And the Earth's axial tilt? Well, it varies too. Sometimes the Earth is tilted more, sometimes less. And the direction of the tilt varies. And the way all of those things, the angle of the tilt, the direction of the tilt, the elongation of the Earth's orbit, the relative directions of all of those things in relation to each other, they also vary. It's very complicated. But they all have an impact on the Earth's climate. And they are predictable and regular, and they tend to coincide with the various ice ages and the glacial and interglacial periods within each. Now, we should note that Milankovitch's theory is not without its critics. There are aspects of cyclical climate change that don't line up as Milankovitch predicted, so his theory is still being refined today. And other factors are certainly known to contribute to these cycles, increasing or decreasing their effects. But these cycles seem to provide the best explanation for at least the large-scale patterns in the timing of the ice ages. And that brings us back around to tarns and moraines. Because whatever the cause of these massive, earth-changing geological cycles, they've left their scars on the planet. And some of us here at the Word of the Week even used to call one such scar home. We used to live on a moraine. A tarn is a pond or lake, but it's a special kind of lake. It's a lake that forms when a glacier scours out a depression or valley as it flows. When the glacier recedes, the hollow traps ice melt and rainwater. That's a tarn. Meanwhile, a moraine is a long line of sedimentary debris, rocks and boulders and soil and whatever, that were trapped in a glacier and dropped as the glacier finally started to melt. This debris forms long lateral lines of rocks and boulders and sediment, and they are very useful for geologists. Terminal moraines show us the outline of ancient glaciers. Those are the moraines dropped when a glacier stops spreading and starts melting and retreating. But they aren't the only sort of moraine. Recessional moraines are lateral ridges that form as a result of temporary stalls in glacial spreading. And medial moraines form where two glaciers crash into each other. Thus, these ridges of unconsolidated debris provide maps of ancient glaciers. Moraines can even dam up valleys scoured out by the glacier, trapping water and forming larger tarn lakes. But what about the moraine one of us used to live on? Well, the angry GM used to live on the densely populated New York City suburb of Long Island. Long Island is a 120-mile-long, 60-mile-wide landmass in the Atlantic Ocean that looks like a fish nibbling at New York. Well, technically it is nibbling at Manhattan, one of the 5 boroughs of New York. 2 of New York City's boroughs, Queens and Brooklyn, are actually on Long Island, and the famous Brooklyn Bridge stretches from Long Island to Manhattan Island across the East River. And Long Island is actually a moraine. Technically, it's 2 lateral moraines which were deposited 21,000 years ago, when the so-called Wisconsin Glacier receded. The moraines left 2 rocky ridges called the Harbor Hill Moraine and the Ronkonkoma Moraine. The erosion caused by the melting ice resulted in a sandy plain and some very nice ocean beaches. The gravel and loose rock were quite effective at trapping groundwater, and thus Long Island enjoys an ample supply of fresh groundwater held in its many aquifers. And now we're bragging a little. The point is, Long Island may just appear to be a fish-shaped island with some very nice beaches, excellent vineyards, and far too much traffic. But like Tarn Lakes and Rocky Ridges, and perhaps even the 200-year rule of the Qing Dynasty, it's really just another scar left of the many ice ages that have scoured our planet as a result of an incredibly complicated dance of massive bodies whirling away in the inky black void of space. And also, Long Island has very good saltwater taffy. You should try some. This has been GM Word of the Week. It's written and researched by the Angry GM and produced by me, Fiddleback. You can support us on Patreon at patreon.com/GMWordOfTheWeek. You can find more at gmwordoftheweek.com and theangrygm.com.